So we're going to lecture today on arrays and array lists. Hopefully we can cover all this in about an hour. The PowerPoint here looks like it's from the previous version of the book, so it's got 9 and 10 all wrapped up into one PowerPoint. I need to go ahead and upload into the content section, the separate chapters, but the concepts are exactly the same. So the idea of an array is just a series of places where you can store values. Like my favorite example is mailboxes in an apartment. You know, you have 100 different mailboxes at your apartment complex. But these mailboxes start with 0, 1, 2, and 3, rather than, you know, room 100 and 101 and 102 like apartments are normally labeled. So an array can be just thought of as a list. Here is an array composed of 5 values. And this one would be element number 0 at index position 0. That would be 1, that would be 2, that one would be 3, and that one would be 4. And so you address them like this. You give the array variable name, followed by the square braces, and then the index value. And if the array has 5 elements, you can go from 0 to 4, because 0 to 4 is 5 elements if you count them. So in general terms, if you say the array is of length n, you can get up to n minus 1 as the maximum element. So let's go into NetBeans and we'll just demonstrate some array code. So you can declare an array in several different ways. One way is just to declare the reference to the array, but not say how big the array is. You could do this. There we go. Now in that video that I linked to, since it's Java, the way you, since it's a C++ video, the way you allocate an array is different. You put the square after the variable rather than after the data type. But that's just C++, but the concepts of that video are all the same. Okay. So we have a reference to an array, but we don't know how long the array is. It doesn't have any data. It doesn't have anything. So this is declaring and then allocating it. So we've declared it, and let's make it an array of 5 values. Okay, there we go. We have room for 5 different values. Now we could write a little loop that would print those out. What I'm going to do is I'm going to ask the array how many elements there are in it, rather than just hard code 5, which I could do. But I want the array to tell me how long it is. So I'm going to do array1 dot length. System.out.println. Let's print out the name with the value of the index and then the value it contains. This is actually a printf because we're using those placeholders. So system.out.printf, and then we have a % holder here, placeholder there, and a placeholder there. And we want to print out first x, which is the index value, because that'll fill in there, and then the actual value that's in that array. And we haven't actually stored any data in here, so let's find out what's in there. So we run it, and it looks like it's all filled with zeros. And that is right. In other programming languages, once you allocate an array, you have no idea what's in there. They could be totally random numbers, or the debugger may set them all with a strange value. But in Java, it looks like they get initialized to 0, which is nice. Now let's change the value, like let's change this one right here, the third one, and make it a 10. So how do I do that? You tell me, what am I going to type here? I want to change this one, but I want it to say 10 when I print it out. It'll be array 1, and it's the third one down, but it's the second value because we're starting at 0, and so I specify the value of it there. So when we rerun it, this one's now going to be 10. All right, there we go. So that's one way. Another is just to declare and allocate on the same line. And this is actually usually how you see it done. Let's give it a different data type. Double array 2. I specify that it's an array by using the square braces. You don't have to put spaces between them. Is equal to new array, new double. And I want 4 elements in this one. So there we have declared and allocated it on the same line. Here we have code for printing the array. It doesn't have to be that fancy. This business, we didn't have to print the index numbers and the name of the array. We could have just written it like this. Well, let's do that on this one now, a simpler version. For int x is equal to 0, x is the length of the array, array2.length, x plus plus. So we're just going to system.out.println that value, array2 at that x. So when we run it, it looks simpler. It's just got all those doubles. And again, they're initialized to 0. So this is code for printing only the values, and this is code for printing the array, including the array name and index values. And let's go ahead and say what this will print out. Now this one, when it runs, I don't know, we haven't copied any values into it at all. I don't know, let's put 10 into each one of those. So array2 position 0 is equal to 10. This is kind of brute forcing in, it's primitive. Array 1, array 2, and array 3. Now when we run it, it's going to print 10, 10, 10, 10. Or we could change those. Make it say 10, 11, 12, and 13. And there we go. Then the third way to declare an array is to give an initializer list inside the curly braces. And I know you've seen those. Let's do that. So we're going to make an array of strings. I'm going to call it colors. And let's put some colors into the array. Red, blue, green. So here's our initializer list. When you use an initializer list, you don't even have to say how many elements are going to be. Otherwise we did. We had to say that this one was going to be 4, and this one was going to be 10. But here, the compiler goes, oh, you need 3. So I'm going to give you space for 3, and I'm going to fill them in with that. So now if we print them out, it will print red, blue, and green. There's a different style of for loop for printing out the array, and that's a for each loop. The book calls it something else, but if you go and you look on Oracle's documentation, they call it a for each loop too. But you use the same word, for. But then, since this is an array of strings, we're going to say for every string in the colors array, print that out. So that's the simplest syntax for printing out an array whatsoever, the for each loop. It's not exactly what you see on the screen, but you pronounce this for each, or for every string in the colors array, print that string out. And as long as this variable name and this variable name match, it's great. You know, I could even call it color and color, but then that's getting kind of close to that word. I'm just going to say string and string S and S there. So when I do that, it's going to print red, blue, and green. And it did it all on one line because, why? Oh, I made one array value and it had those three values in it. They each needed to be enclosed in quotes. That's my mistake. Alright, so what I had was actually an array that was just one element long. So when I printed it, it printed one element. Now it's actually got three elements. And it prints each one on a separate line, as we would expect.
The way you did the first one.
Pardon me?
The way you did the first one.
Up here?
Array, not that one. We actually have the array, one array, and it said 0, 0, whatever, equal to 0, 1.
This one? Yeah.
Yeah. That one, I read it that to show, and then the other one didn't use the show. And these were just showing just a...
Yeah, this one had a fancier print routine. We used printf, and we gave it actually the whole word.
Yeah.
And then we let it fill in the index value. And then we printed the value. So that's good for debugging, you know, making it look pretty for output. Okay, so there's our code. This is a for each loop. And for each loops don't just work with arrays. They work with pretty much any data collection that Java gives you, including array lists and maps and vectors and all sorts of exotic ones. So this is a really useful syntax, and I encourage you to use it as often as possible. The only thing a for each loop doesn't give you is you don't know what index value you're currently at. So if I wanted to print it like this, exactly like this, I wouldn't know whether I was on value 0, 1, 2, 3, or 4. You know, we have no way of knowing what position we are in the array. We just have a copy of that value. We just have something that says red, but we don't know that that's 0, 1, or 2. And the other thing is that we can't change that value. It's kind of a read-only copy. It's just a copy of that element in the array. So if I tried to rewrite this loop so that it would set them all to yellow before we printed them out, so I said for every color, every string in that array, I want that to really be yellow. This is not going to work. We can't change them that way. It's still going to print red, green, and blue. And that's because this S is just a copy of what's ever in that value. It's a brand new variable. If I wanted to change them all to S, I'd have to do it the other way. X is equal to 0, X is less than colors.length, X plus plus. Then I could say colors at that position is equal to yellow. What if I, oh, 2. Okay. This doesn't work because S is just a copy of that value. This does work because we are actually changing the elements. move this up to here. Because then we started changing it. And then when we print it out, this is going to print yellow, yellow, yellow. So there are functions which Java gives you, which will do things like get the sum of the array. I'm not sure if I'm remembering those right away. Here's an example. Sort. Say we create an array and it's got several values and then we want to sort them. There's a function for doing that, fortunately. So let's call this array pi array because we're going to store 3, 1, 4, 1, 5, 9 in it. I'm just going to use an initializer list. 3, 1, 4, 1, 5, 9. I'm not going to write a print loop for that yet, but I want to sort that. I want them to be. So I type array.sort, and I say I want to do pi array. And honestly, I'm not remembering what those second and third digits are, so let's highlight the word sort, do show Java doc, and look at the documentation for that. Okay. So we specify the starting position and we specify the ending position, or we can just leave those values out. So if we only wanted to sort the first two values, we could say starting at 0 and go up to 1. But let's do the whole array. And then let's print it out. If I do this, system.out.println, and I just give the array name, it prints the whole array in a fancy format. Okay, well, no, it didn't print the array in a fancy format, it just printed that. We'll skip that for now. Let's write a for each loop. For each int in the pi array, print that one out. Now if we did it before our sort, it would say 3, 1, 4, 1, 5, 9, but now we've sorted it, hopefully it'll say 1, 1, 3, 4, that kind of stuff. That's the easy way of sorting. You can also write your own sort algorithms and stuff like that, and you know, when you go and take 4-year college courses, they usually make you do that. Right. And sort is, and this arrays.sort is pretty smart. It can sort floats and it can sort ints and it can sort strings. If you do strings, you know they'll be in alphabetical order. Yeah. So that's part of the arrays class, which is built into Java. And if we look, it's got a whole bunch of functions. Binary search, copy the array, check to see if it equals another array, sort, toString. Let's give that a shot. Let's call toString on our array. Let's try to print this out now. System.out.println pi array.toString. Now it should do that pretty thing that I was telling you about earlier. No. I'm sad. I'm doing this wrong. Oh well. Forget that. I'm having a brain freeze on that. So we've seen how to change an element of the array. you use the index value of it. This would change the first element of that phone list and give it a new number. Or if you want to print the second number in the list, you just do system.out.println, you give the variable name, and then in the square braces, you put the index value. So we've talked about array declarations. These just declare the references to the array. It doesn't actually allocate any memory for it. Not until either you do that equals new or you give it an initializer list. So the type is there, and then when we want the array, we say new, we specify the same data type, and then we just say how many we want. Okay, so part of the homework is to make an array and then copy the values backwards into another array. So say we had an array that looked like this. Let's see if we can make this look good. We have a colors array, and before we set it equal to red, well, let's make a new array. String, let's do names. Names are more fun. It's equal to Abe, Bob, Sam, Tiffany, and I don't know, Julie. So if we wrote a for loop now, it would just copy those, it would print those out in that order. So the original has these values in it. I'm going to put in a multi-line comment to make it easier to edit. The original array has got, at position 0, it's got Abe. At position 1, it's got Bob. At position 2, it's got Sam. Position 3, it's got Tiffany. And at position 4, it's got Julie. But in the copy of it, we're going to want this to be index value 4. We want this to be index value 3. This to be index value 2. This to be index value 1. And this to be index value 0. That's one way to think about it. So we can write a loop. So if this is 0 and this is 4, then what formula would turn a 0 into a 4 and turn a 1 into a 3 and a 2 into a 2? It looks like the length minus the index number. Well, not the length, but the maximum index number. 4 minus 0 gives you 4. 4 minus 1 gives you 3. 4 minus 2 gives you 2. 4 minus 3 gives you 1. And 4 minus 4 gives you 0. So let's allocate a new array that's the length of this array so that we have the right amount of space to copy it into. I'm going to just create a variable called length so I don't have to keep typing names.length. That's the length of the array. So let's make a new array that's the same length. Let's call it names2, or back names, or something. And you can use that arrays class that we saw to do this kind of stuff actually. I'm pretty sure that it's got a copy and I'm pretty sure it's got a reverse, but we want to do it ourselves. Okay, so this is going to be the same length as the names array was. Now we need to count them down. Let's just put a counter. We're going to set that counter equal to 0. 0, 1, 2, 3, 4. So while the counter is less than the length, the new array names2 at this position, which is counter minus, the length minus our current index value, is equal to the original array at that specific value. I could have chosen a different name than counter. Let's make that index. So I'm going to do refactor, or heck, let's just call it I. Okay. So there's I, the index value for those are, and here's I. So we're copying them like this. That one's going to go there, that one's going to go there, and so they will be crisscrossed. So this should change elements 4, 3, 2, 1, and 0. But we could put a little print statement to prove that. Using a printf, those are our placeholders. So we will print length minus I, and we will print I. So hopefully this will say 4, 0, 3, 1, something like that. Or it could just blow up. I think that's because length is 5 and there is no element 5. So I need to change length to something more like max index and then subtract 1 from it. So call this one max index and set it equal to length minus 1. Why do we do that? Because the largest value that we can access is 4, but the length of the array is 5. So our maximum index is 4, so I'm taking 1 away from the length. And now I believe it'll work. Oh, make a liar out of me. Let's print these values before we actually try to change them. That should have been less than or equal at that point. Why is this not working? Oh. I am really goofing this up. This should just have been the length of the original array. Names.length. I should have had all this worked out before I did the example. There we go. So we want to allocate this like this. We want it to be the same length as the original array, but then we need to calculate the maximum index value, which is 4. So this is 5 because that's how long the original array is, but max index is equal to 4. Oh, and look at that. It's in an infinite loop. What did I do wrong? I bet you know what I did wrong. There's something missing from my while loop. I checked to make sure I is less than max index, but does anything ever increase I?
Oh,
Yep, I always do that. Alrighty. I'll fix that. And now finally it'll work. So element 0 got copied into element 4. Element 1 got copied into 3. Element 2 got copied into 2. Element 3 went into 1, and the last element went into the first element. So if we print the names2 array out, it'll be in reverse order. So let's just do another for each loop. For every string into the names2 array, we will print that out. Julie, Tiffany, Sam, A, Bob. Mostly in alphabetical order, but not quite. And let's check that arrays class and see if there was a one that would have reversed it. Let's maybe look for reverse. Nope. Arrays dot equals fill sort. Oh, no reverse.
can you do it in just a regular for them, like just putting the minus minus at the end of
Yeah. Yeah, there's more than one ways of getting those numbers to work. We could have counted from 4 to 0 and it would work the same way. Alrighty, that is about it for arrays, but you're going to want to read the whole PowerPoint for it. Then there are array lists. The problem with arrays is that they are a fixed length. So if we wanted to add on a new name to this array, somebody else joins the class, somebody named Becky, well, too bad. We've already got 5 slots in it. We can't stick a 6th person in it. And inserting an item would be a real problem. What if we wanted to add a new student and we wanted to put Becky right here? Well, if we wanted to put Becky right there, then Bob would have to hop over one, Sam would have to hop over one, Tiffany would have to hop over one. So inserting into the list is a problem. You can write code that would do that. If you want to insert items into an array, you have to allocate a new array that's one longer than the original. You have to copy all the old values into it, but make room for that new one. So it's a bit of a burden. It's doable, but it's a bit of a burden. It's much better just to use an array list. So an array list is defined, the syntax is a little bit different. It uses these things. Okay, I think I stopped saying example 1, example 2, example 3. I guess I'll... Alright, so this was around example 3, I believe. I could be wrong. Example 2 was declare and allocating on the same line. Ah, here's example 3. This shows both an array of strings and it shows how to initialize all the elements with the same value. So if you want to initialize all the elements of an array to the same value, you use a for each loop like this. And why would you want to do that? Well, if you declare an array of strings, but you don't create any strings to put in it, then when you try to print them out, it's going to print null pointer. It's not going to look pretty. So that was, I think, example 4, the reverse one. So we'll call this one example 5, initializing an array, I know I spelled that wrong, of empty strings. So, string, we're going to call this, I don't know, months. Is equal to new string, and we want 12 months. Alright, now we're going to print them all out. For each string in the months array, print that month out. Print that string out. Now there's no data in there, of course, but it would be nice if at least, showed just empty things rather than what we're seeing here, which is nulls. Users don't like seeing nulls. We don't really either. So to fix that, we have to go through each element of the array and create a new string to assign it to. So we could do this. For int x is equal to 0, x is less than the length of the months array, x plus plus. Then we could do months at position x is equal to a new string. That creates a brand new string and puts it into the months array. So if we print them out again, we'll get 10 spaces, 12, or not 12 spaces, but 12 empty strings. We can prove that to ourselves. I'm going to copy that code. I'm going to print out a single apostrophe followed by the string.
Let's make that a double apostrophe. This is going to look weird though. Let's use a parentheses. The reason we're doing that is because these strings are empty. We won't be able to see them. But now we see that there's nothing in those strings. So to initialize the string, you actually have to use just a pure old for loop, because a for each loop doesn't let you change the contents of the original array. That makes sense? Cool. Array lists. Problems with arrays. They are fixed length, meaning that to append or insert a value into an array is a real problem. You have to allocate the new array, copy the values of the old array into the new one, and add the new one appropriately. Now that's a pill, we don't want to do that. Here's how you declare an array list. Array list is actually a class. So we're going to say we want an array list of ints. However, array lists cannot work with primitive data types. They cannot use the lowercase variable names. So we can't use int, float, long, double there. That'll give us an error if we try to do it. But we can use the helper classes. We can say that we want an array list of integers. And I'm going to call this iList for integer list. Is equal to new array list. And there we go. So that's kind of a goofy syntax. For one thing, it's yelling at us that that it doesn't know what an array list is. That's because we did not go up and add the import statement up at the top necessary. And we could do that, but I'm going to cheat and let NetBeans do it. Add import for java.util.ArrayList. Well, I'll go up here and I can type that. Import java.util.ArrayList. There we go. Now when I come back down, those errors will be fixed. Way down here. Way down there. Okay. We'll see that if I tried to make an array list of something with a lowercase in front of it, like a double, and we called it dlist. Trying to be consistent. This gives us an error. This type has to be a class. It has to be a reference type. It can't be a primitive data type. That's just the way that array lists work. So to fix that, if we wanted to write code that had an array list of doubles, we would have to use the helper class like that. Well, now we have these two array lists. We can insert some values into them. iList.add. Well, into my array list of integers, I'm going to copy a 10. I'm going to add a copy of 20. 30. Then I can print it out the same way I did before. There's two ways of printing out an array list. One is to use a for loop and one's to use a for each loop. Let's use a for loop first. We will start our index counter at 0. We will go out to the length of the array list. The syntax for this is a little bit different. It's iList dot size. Why isn't it called length like it was on the other one? I don't know, but it's called size. and then we could print out. And since it's an array list and not an array, I can't do that. Instead, I have to use .get, which does the same thing. But you can see that the syntax is different. Now when we do that, it'll print out 10, 20, 30. Or it'll blow up. Oh, why did I have X here and I here? I is left over from a previous bit of code. Let's fix that. There we go. So to get the first value out of an array list, use .get 0. The second is .get 1, and so on. That's different than an array, but whatever. To get the length of the array list, you use .size rather than .length like you did with the array. So things you can do with an array list. You can sort them. You can append a new item. You can insert an item into it. You can remove an item from the list. And these are the things that are real hard to do with an array, but they're easy to do with an array list. So let's add some more values to our array list. We've already added 10, 20, and 30. Let's put 100, 200, 300. System.out.println, let's print them out. So let's use a for each loop. So we can print the array list out with toString. That didn't seem to be working with arrays, but I believe we can with array list. So system.out.println ilist.toString. Now when we print it out, it should say 10, 20, 30, 100, 200, 300. That's a quick way to get the output of an array out. But let's say that we wanted to put a 5 right there. ilist dot, it's not insert, but when we call dot add, well, yeah, let's differentiate. Dot add will append to the list, but dot add, where you specify an index value, will append, will insert at the specified value. So ilist.add, we want to put a 5 right there at the beginning of the list. Since we're inserting into the beginning of the list, we want this to be the new element 5. The new element 0. It is complaining because it didn't like the fact that we weren't inserting an integer with a capital I. So let's say that at position 0, we want to insert a new integer that contains the value 5. And that works. So now when we print it out again, we'll see a 5 is the new beginning of the list. Or not. excuse me. There we go. So by inserting a, by dot adding at position 0, we inserted it into the beginning of the list. So you can specify the index value, and if you want it to be at the beginning of the list, the index value should be 0. So dot add value will append that value to the list. Dot add index comma value will insert it. Insert 0 comma value will insert at the beginning of the list. And note, to use anything else except for just dot add by itself, we have to actually get it to be the correct type. To get dot add to work properly with a specified index, we have to be adding an object of the specified type of the list. In this case, it was an integer. So that's why we did that.
So
So lastly, I guess let's write a loop that'll let us enter values into an array list. So to do that, we're going to have a scanner. And we know we need to go add the import for that. I'm going to let NetBeans add it for me. Add import for java.util.scanner. And then let's do double v. V is the value to add. Now, let's just do a while true loop. So until we hit a break statement, we're going to keep repeating this. System.out.println, enter a value to add to dlist. And then string s is equal to in dot next. Oh, I could just use let's just use next double. Double value is equal to in dot next double. Now we have our value, but we haven't let them exit. Print or minus 999 to exit, whatever. Okay, so we let them type it in. If the value that they typed in is equal to negative 999, we will break the loop. Otherwise, we're going to add it to our dlist. Now, do we want to append these values to the end of the list, or do we want to insert them at the beginning of the list? I don't know which would be more fun. Fun being a relative term. Stop laughing. dlist.add, and if we add the value all by itself, there we go. It'll keep appending them to the end. So then when we print them out, system.out.println dlist.toString, enter a value. Okay, 2016, that's our value. Now we have an array with one element in it. Excuse me, an array list. Let's type in another value. What's our favorite year? 1968. 1668, whatever. Okay, 2016, 1668. Now we're going to add the number 3 to it, and so on. So each time we're just calling .add, and it's adding a new value to it. And they're going in the same order. But we could change this so that it was adding them to the beginning of the list each time. So we would just say at position 0, I want you to add a new double with that value. Now to build a list in reverse order. So let's type in a 1. There, now we have a list with a pretty 1. 2, well now it's 2 and a 1. 3, 3, 2, 1. Alright, I can think of only one more topic that would be appropriate for this intro, which is to point out that an array can be composed of your own data types, not just the built-in data types. You can make your own class and then make an array or an array list of that class. So let's do that. That almost should be a whole new lecture though. How long have we gone on? Oh heck. Let's finish this out. Make it an hour long. Okay. So here's our goal. We'll make a class that contains someone's name and age, and then create an array list that contains objects of that class. We're going to need a new class to do this. So let's just call it, I don't know, pdata for person data, something like that. So new Java class, let's call it pdata, and we want their name and their age. So string name, int age. Let's make a constructor where we can specify the name and the age all at one time. So public pdata, we will pass in a name, we will pass in an age, and then we will set this dot name equal to name and this dot age equal to age. And let's make a toString so that we can print this data out nicely. Public toString. We will print out name equals %s, age equals %i, followed by this dot name and this dot age. So does that make sense? That's the kind of stuff that we did. Okay. And it's of type string. Now if we really wanted to make it a good class, you know, we would make these private and, you know, that kind of stuff. But we haven't added a get name, we haven't added a, you know, oops, I slipped into C++ there. We haven't added set name or get age or set age, so it's a really primitive class. Why is this a problem? Oh. Not system.out.printf, it's toString. It actually needs to return that. So, what we're going to do is string s, that's our return value. S is equal to so we will use string.format, which does the same thing as printf. Yeah, so string.format like that, and we will just pass in these things, and then we will return that string. So that's what our toString method is going to do. Okay, I'm going to go back to Java application. We're going to make all of this stuff over here main2 so that it will no longer be called. I'm going to make a new main let's test out our class first to make sure it works. So P data person1 is equal to new P data, and it's capital D, so Joe, who is 10. And then let's print P1 out. System.out.println P1 equals followed by P1. And that'll invoke the toString method on it. Okay. Ew, and it blows up. Format specifier conversion problems. Well, that has to be over here. %s. Oh, it's %d, isn't it? In this language, d is an integer. If I'd made this a double, then I'd use %f. Okay. All right. So the person's name is Joe. His age is 10. So the class is working. Let's create 3 different people. Person 2, Sally is 11. Really? Person 3 equal to Denise, who's 9. Alrighty. Now let's add those 3 people to an array list. Well, first, let's make an array of pdatas. So this would be pdata, and I'll call it parray, is equal to new pdata. And it's going to be 3 elements long. But if I print those out, it's going to say null, null, null. But we can assign them. Parray position 0 is equal to P1. Parray at position 1 is equal to P2. Parray at position 2 is equal to P3. Really, we would probably be allowing data entry, but same idea. Let's do an array list. So array list of pdata objects, we will call it plist, is equal to new array list. That syntax is so goofy looking. There we go. And then we will just add those. plist.add P1. plist.add P2. plist.add P3. Okay, and now we could print out those arrays just with a for each loop. For each pdata item in our plist, system.out.println p. And this should print all 3 of our people. There we go. Joe, Sally, and Denise.